that. So certainly international cooperation is one highlight of the Chang'e 6 mission, and as we know, the moon has always been an object of wonder, a site of romance for the Chinese, and of course an interest of scientific research for people around the world. And countries are really taking this opportunity to try to deepen their understanding of this planet. We are seeing that the Chang'e 6 is carrying international payload from Pakistan, from France, from the European Space Agency, as well as from Italy. So what does it mean to have this joint efforts in the joint exploration of the moon?
Well, that's for China, for a space capable like China to conduct international cooperation will be very, very important and very, very meaningful for us. You see that today China is a big country in space field. We have so much launches and so much space missions, but we are not, we view ourselves, not recognize ourselves as an advanced country in space field. To become an advanced country, we have all kinds of measures. We can have all kinds of benchmark to become an advanced country. One important thing is the international cooperation. So we think that the international cooperation is extremely important for us to become an advanced country. To achieve this goal, we not only have this kind of cooperation in manned space flight, in the applications, space applications, the Earth observations and the space science, but also in these lunar missions. You know that today it's already almost become a tradition for the space capable nations to have the payload, especially scientific research payload from other countries when they conduct a space mission.
Yeah, and this is not the first time China is
not
carrying
the first time
international
for China
payload.
and other countries. So for all these missions, they have the payload from other countries.
Live feed from the launch pad. It looks gloomier than like 10 minutes ago. Are you concerned about the weather condition?
You see, as you mentioned, the weather condition is a very, very important factor for us to consider it. But you know that whether we go for launch or not is a decision of the commander of the headquarters of the launch site. So you know that for the influence of all kinds of different factors, we have the criteria.
5 minutes to the countdown.
Yeah, T-minus 5 minutes and counting.
Right. So we mentioned earlier we have this narrow window and multi-orbits technology. Does it mean that it's the rocket could have the go-ahead to blast off in the next 50 minutes starting in 4 minutes?
Yeah, exactly. So as I mentioned, the 17:27 o'clock will be the front edge of our launch window. So this is the earliest moment we can conduct the launch. But if some small error happened or something we must handle during the process, we can stop this launch process and wait. And if the problem can be solved within 50 minutes, we still have the chance to conduct the launch today. So that's the narrow launch window because the capability of our powerful Long March 5 rockets can provide some design margin for the launch window. So according to its capability and what we need for it, we can expand the time period permission for the launch. So this is a reason why today we can choose the narrow launch window. So it brings more chances for the launch today. So we can have the tolerance if something wrong happens.
And let's circle back to our discussion about international cooperation. We understand that the Outer Space Treaty in 1967 is considered to be the cornerstone of international space law. Over 100 countries signed up to this legally binding treaty, which details the rules governing the exploration of space, peaceful exploration of space.
So as a space capable nation, China also signed this treaty very, very early. So today, to be a...
The announcement, any command from the scientists there, the engineers there, is making us
all the ground staff has withdrawn from the launch complex.
Right.
So at this moment, as I mentioned, so there will be many critical steps For instance, the rotation or the withdrawal of the service arms from the previously attached to the launch tower. Right. The cables, the pipes, you may notice that maybe at this moment the white fogs has already disappeared.
That's right.
So that means that the refueling process has already been ended. Yes. So it's all on its own. And during this following seconds, we will also transfer the electricity power supply from the service tower to our launch vehicle itself to use the storage batteries on board our Long March 5 launch vehicle.
Sure. Now, 2 minutes before the launch, we'd like to give our viewers a little bit more background on this mission. The Chang'e 6 spacecraft will embark on a 53-day journey to the far side of the moon and back, returning lunar soil and rocks to Earth.
Great. That's what I mentioned. The arms will turn from this
Finally being detached from the carrier rocket.
And all kinds of cables.
Is that a final sign that all systems go? The rocket is ready to go.
Yeah.
As scheduled.
As we mentioned, all kinds of cables detached from the launch vehicle. We also have really air conditioners in the payload fairing.
And really at this moment, I'm pretty sure that the engineers there, us and viewers watching this moment are holding their breaths.
Yes.
And again, the highlight of this mission is that the Chang'e 6 will be traveling to the far side of the moon, retrieve lunar samples, and bring them back to Earth. And if successful, this will be a history.
You can see the 4 boosters.
50 seconds countdown. Well, certainly this mission will help us understand the Earth's formation, its evolution, over billions of years. 30 seconds countdown.
The onboard computer is now in charge of everything.
All right. And certainly we'll bring you every detail from the launch as the rocket blasts off. Final 10 seconds countdown.
3, 2, 1. Ignition.
You're now watching live feed from Wenchang's Satellite Launch Center. China's Chang'e 6 mission blasts off into the sky. It's all systems go, Professor Yang.
So magnificent. And now the tower is cleared.
It's now starting its epic journey to the moon.
So at the moment, 17 seconds after liftoff will be the pitch over, change the direction.
Right.
And now you can see this is a video captured by the camera mounted on the launch vehicle. Actually speaking, on the core stage, you can see 2 of the rocket boosters.
Right. Are the cameras infrared?
This is a visible light camera.
Visible light camera.
Yep. And you can see the flames of the boosters.
Yeah.
Each have 2 rocket engines, YF-100 rocket engines with a thrust more than 120 tons.
Sure.
And the booster will work for nearly 3 minutes.
3 minutes.
Yes.
And then it will detach from the
We can hear from the ground stations. The voice comes from the reporters of the ground stations. They mentioned that the telemetry received normally and the spacecraft fly normally.
Now, as we mentioned, this mission will last for 53 days, much longer than the previous mission, the Chang'e 5. It's going to make a soft landing on the far side of the moon, somewhere around the Aitken Basin. And then it's going to bring back lunar samples from the moon.
Next step will be the separation of the side boosters. We have 4 boosters within several seconds.
As we were discussing, Professor Yang, how long would it take for the probe to actually land on the moon?
Well, the powered descent only lasts for several minutes, less than 10 minutes. But they will wait for this moment on the circumlunar orbit for several days. So that depends on the design of the whole mission profile. And next, we will be seeing the separation of the booster soon.
Now, even the launch moment was successful, we couldn't say that this entire mission is a success because every step of the way will be pivotal for the entire.
Okay, great, beautiful.
Boosters.
Yes, all the 4 side boosters separated normally.
Applause from the control center. And that's certainly another step forward.
Yes. So the rocket will continue to work several minutes. So and the next critical step will be the separation of the payload fairing.
Right.
Because you know that it's in the ascending phase and its altitude is begin go higher and higher. So at a certain moment, we do not need the payload fairing to protect the probe.
Right. We are now a little over 4 minutes into this mission, and it looks like so far so good.
So now it's a flying of the first stage. So as I mentioned, the first stage have 2 rocket engines with liquid hydrogen and liquid oxygen as a propellant.
Sure.
And each of the okay, this is a 3D animation. Today, at this moment, we can see the fuselage of the first stage. And as I mentioned, we have 2 rocket engines on the first stage of the YF-77 rocket engine. Each have a thrust more than 50 tons. And we just heard a voice that's the ground station, the radar tracking the.
Because we can now see that beautiful view of
yes,
the Earth.
actually speaking, it's already, I believe, it's already more than 50 kilometers high. And when it is high enough, as I mentioned, we will conduct the separation of the payload fairing. Oh, you can already see on the left our screen, we can see the camera inside the payload fairing. We've already seen the scene inside the payload fairing.
Right. That's, of course, giving us a very clear look, a very clear vision of the payload from inside the probe.
Yeah, inside the payload fairing. So we can see that the Chang'e 6 probe is stored in this payload fairing.
Right.
And next, with the okay, great,
it's
beautiful.
Opening up.
Separated. So we don't need the, as I mentioned, because it's already high enough, we don't need the protection of the 2 pairs of payload fairing. So it's already in outer space.
So next phase will be the second stage ignition.
First, we should separate the first stage.
First stage, right.
Yeah. Liftoff will be the first shutdown of the first stage. Sorry, the separation of the first stage.
Separation of the first stage followed by the second stage ignition. Right.
Yeah.
Wow.
So this is the 3D animation, and this is a video from the board on the rocket. Now you can see the beautiful Earth and the curve of the horizon of the Earth.
It really looks like, I know it is a technically demanding and challenging mission, but it's also a very romantic and beautiful journey.
Yeah, what you see now is just above the Pacific Ocean.
Right. This mission is going to last for 53 days, and it consists of 11 phases. Every detail, every single action could have an effect on the entire mission.
Every step, as you mentioned, every step is important. Every step is critical. So although the thrust of the core stage, as I mentioned, of the first stage is much smaller than its 4 boosters, but it will work longer because the liquid hydrogen has higher energy. Great, the flight is normal according to the voice reported by the ground stations.
Right. So correct me if I'm wrong, Professor. The spacecraft consists of 4 separate components.
Exactly.
There's an orbiter, lander, ascender, and the re-entry module. And
exactly.
After launch, the Chang'e 6 will travel to the moon and enter lunar orbit, and the lander and the ascender will travel to the surface.
Yes.
While the orbiter and re-entry module stay in orbit.
The combination of the orbiter and the returner will stay in the lunar orbit to wait for the ascender.
And the ascender and the lander will touch down at the far side of the moon and collect samples to the re-entry module.
No, to the ascender. So they get the samples in the container. Okay. Great. The first stage has separated.
First stage separation.
And now will be the ignition of the second stage.
So my understanding is that the ascender will blast back into lunar orbit and transfer the sample to the re-entry module.
Look, you can see that we can see this is a camera mounted on the second stage. We can see the first stage separate and going far behind the second stage.
Another view from
this is a view of
payload.
We can see that there is also a camera mounted near the rocket engines, so we can see the working of the rocket part of our second stage. So we can monitor. It's also use liquid hydrogen and liquid oxygen as the propellant. It will work much longer, although the thrust is much smaller than the first stage. But it is very unique because it will ignite twice. So with the first ignition, it will burn several minutes. So at the moment, about more than 10 minutes after launch, it will shut down first. So at this moment, it will enter what we call the parking orbit. And it will float in this parking orbit for about 10 minutes, which calls this coast phase.
And once it enters orbit, well, before it touches down on the moon and after it goes into orbit, one very important step is to slow down the probe. Just to make sure it makes a soft landing on the moon.
So you know that there are two steps. The first is what we call the lunar orbit insertion, which means that we slow down the vehicle from the translunar orbit to the circumlunar orbit. And then we, with what I mentioned, as you mentioned, the combination of the lander and ascender, with the combination of these two spacecraft, we use the propulsion system to slow down the vehicle from about 1700 meters per second to zero. Also, the altitude from about 100 kilometers to zero within only 10 minutes. So this is also another critical step.
Fascinating. And another highlight of the mission is that there's this relay satellite.
Yes, the Magpie Bridge 2.
鹊桥 2 in Mandarin and Magpie Bridge 2 in English. So simply put, there is no direct line of sight from the Earth to the far side of the moon.
Absolutely.
And that's why we need that relay satellite to learn more about what's going on there and also receive data.
Well, you know, as you mentioned, the Magpie Bridge 2 or the 鹊桥 2 data relay satellite. But I should emphasize that 鹊桥 2 is an extremely important part for our sample return mission from the far side of the moon. We cannot see our probe, the lander on the lunar surface with our ground stations. And not only, you know, that this time the 鹊桥 2 or the Magpie Bridge 2 not only acts as a bridge to conduct the communication, but also it is very important for us to measure the precise position and velocity of the lander, the coordinate of the landing point, and also during the ascending phase of the ascender. You know that the basic requirement for rendezvous and docking is that we must ensure the ascender entered an orbit with the same orbital plane of the orbiter.
Sure.
So that's really important.
So does the Magpie Bridge providing data or visual images from the far side of the moon?
Okay, we can see, we hear the voice of the ground commander that the second stage has already shut down for the first time. Now the whole combination of the rocket and our probe has entered the coast phase. So it will last about 10 more minutes.
10 more minutes.
You know that for any probe to the moon, we must have or conduct the translunar orbit insertion near the equator. But you know, although you know that Hainan province is the most southern province of China, but still it's not located on the equator. So that is reason why we need a coast phase. So when the first shutdown of the second stage completed, we will have a coast phase about 10 more minutes, and then we ignite again near the equator, and then it will be the translunar orbit insertion. We can just wait.
So again, the Magpie Bridge 2, does it provide data or visual images of how the probe is there retrieving samples from the Aitken Basin?
Actually speaking, the camera mounted on the lander will monitor the whole sampling procedure. And then the signals of these videos will transfer first to our Magpie Bridge 2 data relay satellite and then forward it to the Earth.
Is there a time delay, I would imagine?
The time delay is only 1 more second. You can
a little
neglect
more than
that.
a second.
Yeah, because you know that it's too far from the Earth. The distance is more than 380,000 kilometers away.
What if the command center gives some orders to the probe? Does the Magpie Bridge 2 also do the job?
Exactly. So we cannot directly send the command to the probe, to the lander, data relay satellite. So you can see we can based on the real data we get from the parameters measured by the sensors on board our spacecraft. When it reaches the equator, it will ignite again.
Yeah, or different types of lunar excites. Which part is the most technically challenging?
Absolutely, the sample return will be the most challenging one, like this one. You know that, as we discussed before, China has already conducted 3 phases of the lunar exploration program in 3 very simple Chinese words. 绕,落,回.
Right.
绕 means orbiting in English. And you know that we conducted this by the Chang'e 1 probe and the Chang'e 2. And 落 means landing. Landing conducted by the Chang'e 3 and the Chang'e 4. And 回 means sample return. So we conducted with Chang'e 5. So you see, for each one step, we also need to do the things on the previous step. For instance, if you want to conduct a landing, you must have the orbiting. And for the sample return, you must first have the orbiting and then the landing.
Yeah, it's always a follow-up mission of the previous one.
So we master the key technologies one by one.
So China's lunar exploration mission, what is the final aim of this entire mission?
Well, you know that today we are already in the 4th phase of our lunar exploration program. So for this program, we will set up or build a permanent base on the lunar surface called the International Lunar Research Station. So it is an international cooperation with other countries. So today already have many countries involved in this program. And you know that in the 4th phase of our lunar exploration, we only have the Chang'e 7 and the Chang'e 8 probes landed in the South Pole regions of the Moon. So they will form the most essential or the basic configuration of our research station. So we can see that in the commanding or flight control hall of the Wenchang Space Launch Site, we can see the time of the total flight duration. Exactly. So this time, we also can see from this 3D animation, which is driven by the real data, we can see the real attitude and also the position of our combination of the Chang'e 6 probe and the 2nd stage of the Long March 5.
Yeah, and of course these scientific data are crucial for ground control command to monitor the status of this spacecraft.
So as I mentioned, the spacecraft need to fly from Wenchang Space Launch Center, spacecraft launch site to the equator. So it do need several minutes.
Sure. So again, our plan to build a lunar research base.
Exactly.
Would it be on the far side of the moon?
It still depends on which is the final chosen position. But absolutely, it will near the South Pole, whether it will on the near side or on the far side of the moon. But still, you know that we've already talked about the Chang'e 2 data relay satellite. It is very interesting that the Chang'e 2 chose a quite different orbit comparing with its successor, the Chang'e 1. So you know that the Chang'e 1 located in what we call the halo orbit, very close to what we call the Earth-Moon L2 point, which is far from the moon, about actually speaking about 70,000 kilometers above the moon. But this time we choose a high elliptic
Light duration.
Yes. So the next critical step will be the reignition of the second stage.
Reignition of the second stage.
Also named as the Translunar orbit insertion. So at this moment, the combination of the spacecraft are in what we call a parking orbit.
Parking orbit.
Parking orbit. So the altitude of this orbit is usually only about 170 kilometers to about 200 kilometers in altitude. So it's not very high from the Earth, but still it is outside the atmosphere. So it is possible we fly in this orbit in a very short period, for instance, this time in about 10 minutes, to fly to the equator.
You mentioned just now the long-term goal of China.
Robotic missions and manned missions, the budget is much lower than the manned missions. For instance, for lunar probe or sending return mission, we only use the Long March 5 mission, Long March 5 probe, Long March 5 rocket, which can send about more than 8 tons to payload to the moon. But for a manned mission, we at least need the capability more than 40 tons. You can see how the difference is. And you see that, so each one is necessary. For the robotic missions, you can have wider choice of in which point you get the samples and in which point you conduct the research. But for the manned missions, you know that we can brought our experts to the moon. For instance, during the Apollo 17 missions, a scientist, Mr. Harrison Schmitt, were brought to the moon. You know that he's a scientist and he conducts all kinds of very complex operations on the lunar surface. So this is very meaningful and very necessary.
But of course, he must have undergone intense training in order to become an astronaut.
Yeah.
Right. Right. So this race back to the moon is going on in different countries.
I don't recognize it as a race. You see that China developed our space technology, conduct our lunar program, not only the robotic program or the manned lunar program, according to our needs to promote our high technology. To have the space technology, to develop these technologies, benefit our daily life, benefit our progress of the society. So we don't have the risk of with other countries. Whether the other country will be earlier than us or behind us, we don't care about that.
Yeah, China has always maintained its position that the exploration of space is peaceful and the benefits should be shared by all of humanity.
Exactly. And you see that for the human being, the moon has other very important meanings. You know that today the energy is a great problem for the human being, for the sustainable development for the human being in the future. But you see there are helium-3, very sufficient helium-3 resources on the lunar surface. Although today it is still too early to talk about collecting the helium-3 at this
for the
stage.
Earth's benefit, but the resources, the reserves there could power Earth for centuries.
Maybe next century, maybe later. So if in the future, theoretically speaking, it is possible for Earth to master the technology of controlled fusion power. If we can get or master the technology of controlled fusion power, it will be the completely green energy resources for the human being. And you know that, as you mentioned, the helium-3 on the lunar surface can be used for thousands of years for human beings. So that is the reason why the lunar exploration is so meaningful today.
And that could certainly help address the climate and energy crises that we are facing today on Earth.
But I still should emphasize that's still too early to talk about this now.
It's a blueprint. It's a long-term goal.
It's a vision.
Yeah, it's a vision.
So about 5 minutes left for the second ignition of the second stage. So we will conduct the lunar orbit insertion very soon. So you may notice at this coaster phase, we also have the control. You can see that although it is not a real video stream, but the 3D animation, as I mentioned, is driven by the real data, by the real parameters. So you can see that the attitude or the direction of the combination of the spacecraft is still very, very stable because we have the attitude control engines on board our second stage of the Long March 5.
Sure. We're now about 24 minutes into this mission, the Chang'e 6. This is a milestone mission, as it will mark the first time that a spacecraft will make a landing, hopefully, a soft landing on the far side of the moon and bring samples back.
We have a measure to adjust the duration of the coaster phase to have different choices of the launch window. So this is also a key technology we've already mastered several years before. And with this help, we can extend the launch window. And as I mentioned, as we've already discussed, you may remember just now, we've already discussed the influence of the weather. There are all kinds of things that can influence the possibility of a launch. So to extend the launch window, we master this technology.
Right. So for humanity to further explore the moon, it's not only for us to get a better understanding of the planet, but also for us to go deeper into the universe.
Yes.
For example, maybe perhaps one day in the future, the moon could be used as a launch pad.
Yes, quite right.
For our journey to Mars.
Yes, and according to the analysis of many experts, it will be cheaper. That although I don't agree that the human being today we should colonizing Mars, until now the human being has not mastered the necessary technologies to colonizing Mars. But I always support that the human being now we should set up a permanent base on the Martian surface. It is very meaningful and also very important for us. For this goal, the most difficult thing or the most tough point for us is to have a sustainable or a low-cost transportation system between the Earth and Mars. And during this process, I think there are two things we should consider. The first one is the on-site resource utilization, either on the Martian surface or on the Earth. On the moon.
On the moon.
Yeah. So if we can utilize great, we can see the scene in the.
They all look very
the flight
relieved,
control center.
relaxed, and that's certainly a good sign for the mission, meaning
Yep.
the most
So
risky
now we are very
part.
close to the second ignition.
Right. You do have a long-term vision, Professor Yang. You were talking before we were able to understand the far side of the moon and build up a space there. You were thinking about building a camp, building a research base on Mars.
Yes, like that we done in Antarctic region. So that today we China already have more than maybe 4 or 5 stations in the Antarctic region, in the continent. But that it is also necessary for us to do the same thing on Mars. But to do this, that the cost of the transportation between the Earth and Mars is extremely expensive now. So what we should do now is to conduct all kinds of technical measures to reduce the cost greatly, remarkably, for this purpose. So the first step, maybe just what SpaceX have already done, we should also master the technology of reusable launch vehicle. And in the future, that today we already have many state-owned companies and the private companies in China is now developing this technology.
Scientists and engineers at the Ground Control Center are looking relaxed than prior to the launch.
I believe they are also waiting for the ignition, the reignition.
Yeah. As we said, every minor step of the way is pivotal for the success of the entire mission.
Yep. As I mentioned, the coaster phase will last for more than 10 minutes, quite long procedure.
Second stage ignition, the second
Reignition.
Reignition.
Okay, great. We heard the voice.
Another round of applause from the engineers.
Yeah.
on
So
Earth.
the second ignition, the second burn will last for several minutes.
Second stage boosts for
7.8 kilometers per second. But if you want to go to the moon, the velocity must reach to about 11 kilometers per second. So there is a great gap between these two velocities. So that is reason why we need the second ignition, just near the equator. So we utilize the second stage to conduct the second burn to have the translunar orbit insertion.
It's pretty fascinating to think that what's keeping scientists, engineers, and amateurs alike, keeping their passions is the uncertainty and the unknown of the vast reaches of the universe. There's just so much to explore.
Well, that is curiosity. I believe it is human nature for not only our engineers and scientists, but for all human beings. And also, I should emphasize that to study, to explore the universe is also even very, very important for us to know the destiny of human being. That why we conducted so much missions to study the history or evolution of the moon, because with only in this measure we can have a more precise prediction of the fate of human being in the future. So that after maybe 5 billion years, the sun will become a red giant, and at that moment the earth is not habitable for human being. So we must know or have a better understanding, a better prediction of what will happen in the future.
Nothing is impossible. And just think about hundreds of years ago when scientist Galileo Galilei invented the space
astronomical
telescope, and we were able to have the first sight of the moon,
especially the craters on the moon.
And now the Chang'e 6 mission is bringing with it a payload from Italy, from scientists there. It really tells us how much humanity has, made leaps forward in our exploration, our passion, and our renewed interest in the moon.
As mentioned by our guest from Pakistan, so their CubeSat will have a very powerful function to take photos on the lunar orbit. So I believe that it is very beautiful, that's the photos of moon, and also very, very helpful for us. Although, it is impossible for us to enjoy the far side, the sightseeings on the far side of the moon. But with the orbiters, we can do this. And even today, for instance, the US has a probe called the Lunar Reconnaissance Orbiter. It can even take the pictures of the trail. Miss Wang Yaping, the first space teacher of Times, press my best wish to her to fulfill this dream. And also, I should add, than this long march.
Much heavier than an unmanned mission is because it has to bring with it the life-supporting materials like water, food, for example, to really keep our astronauts alive and functioning well on the moon.
That we can have a comparison between the Shenzhou spaceship and the future manned spaceship to the moon. You see that the total mass of our Shenzhou spaceship is more than 8 tons. But the difference between Shenzhou spaceship and the spaceship to the moon is that for the spaceship to the moon, it must have much greater capability to